So this is about organic chemistry and the study of carbon-containing compounds. Carbon atoms are really versatile building blocks here, partially because they have 4 valence electrons. So here, 1, 2, 3, 4. And sorry if it's loud, this was the only place I could record today. So that just gives 4 places for it to bond to. They're very, very versatile because they can assemble, like another carbon can attach. So you can see 2 carbon, 3 carbon, 4 carbon. You can like go to 20 carbon in length. You can also branch these or add double bonds to them, or they get so long they can come back together and connect in a ring. So they just have so many ways to assemble that they're their whole own area, organic chemistry. Organic compounds are anything that has a carbon-hydrogen bond, so also known as a hydrocarbon, this bond. Carbon and hydrogen are both nonmetals, and they share valence electrons, so that makes them a special type of covalent compound. So if we go back to this one, from what we just learned last class, this would have been called carbon tetrahydride as a covalent name, but because it's organic, because it has carbon and hydrogen, it has its own naming system. So these hydrocarbons have some things in common, only the ones with all carbon and hydrogen. They're nonpolar because this is a nonpolar bond, which means they just don't interact with other substances very much. Insoluble in water, so they don't dissolve in water. And as these are all gases, up to 4. Once you get to 5, it's a liquid. And if you get to 18 in your carbon chain, it becomes a solid. So why should we study carbon? All life is built on carbon. Your cells are like 75% water. The rest is all carbon things. So like, these are some examples. In a cell, you might see granules and chloroplasts. If you go back to what those are made of, they're starch, and you can see each of these little starch components. And if you look at a single one, it's called a monosaccharide. And this is a carbon, 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 carbon. It's a carbon ring with hydrogen and oxygen coming off of it. Chromosomes make up DNA, which are called nucleotides, each of these parts. And these are also carbon rings. Filaments are polypeptides, which are amino acids, and you can see those are carbon. And then this is a fatty acids, long carbon chain, which is part of adipose cells. So if you look at all the stuff in the cells, you can go back to carbon structures. Okay, now we're starting to get to how to name these. It really is based on the longest carbon chain. So you can see this is called methane. The meth comes from 1 carbon. Eth is 2 carbons. Prop, 1, 2, 3. Prop is 3 carbons. And bute is 1, 2, 3, 4 carbons. You can attach functional groups to these. So if you replace one of these hydrogen here, if I replace this with an OH, that would be a functional group, anything that can replace an H. So there's main functional groups, and these are the ones that we're going to learn. They're the second part of the name. And then there's other ones that are less significant that can be included, but they would be a prefix. We're not going to learn about these in intro to chem. We're just going to learn these ones. All right, so we're going to learn the 4 main areas. Alkanes are all single bonds. You can see these are all single. So this would be methane because it's 1 carbon, all single bonds. Alkenes, you can see this red here. It's called a double bond. So if you see a double bond, it's an alkene. So the example here, 2 carbons, ethene, because it's an the ene comes from it being an alkene. The eth comes from the 2 carbons. This one includes this hydroxyl group. So if you see an OH on there, and only an OH, replacing the carbon, or a hydrogen, sorry, that is a hydroxyl group. So these 2 make F, And then because it's an alcohol, it's anol for the ending, ethanol. And this one, again, 2 carbons, so F. And then if it includes a carboxyl group, that's this. When drawn into the structure, it looks like this. So this would be called ethanoic acid. So take a minute and pause the video and try to see if you can tell, is this not name, but is this an alkane? Is it alkene, alcohol, or carboxylic acid? Do that now and pause the video before I go through the results. All right, the first one, hopefully you noticed, is all single bonds. Every single of these single bonds. So this is an alkane. This one has 2 functional groups, but only one of them was with a main functional group. This is a main one, this is secondary, so it's not counted as part of the main name. So this would be considered, because it has a COOH group, a carboxylic group. Our next one, again, has 2 main parts, but this is, well, 2 functional groups. This is the main one. So this double bond, which makes it an alkene. And our last one has 2 again. This is considered an OH. The O is always connected to the carbon. That's what that line means. So this is an alcohol. All right, so to name these, first find the longest chain, 1, 2, 3, 4. And then we would call that, so 2, 3, 4. Next, use the number of carbons, so 4 makes it bute. We're going to put that into the name, bute. Next, determine if any functional group is present. So we see an OH here. OH is here. So that makes the ending, it's an alcohol, the ending is anol. So butanol. If you can get that far, you're doing pretty good. The next thing is the harder part. Always number the functional groups. If it's a double bond or a hydroxyl, this is a hydroxyl. So if it's this or this, it might need a number. So you want to number your carbon, and you can number them this way or this way, because if I took this and I rotated it upside down, the carbon could be going the other way. So this first carbon here could be a 1 or a 4. Always pick the lower one. It's a 1. This could be a 2 or a 3. The lower number is 2. The third in line here could be carbon 3 or 2. 2 is the lower number, so it's a 2. And the last one could be a 4 or a 1. So 1 is the lower number. So in reality, this is a carbon 1, and this is a carbon 1, and these are both 2s. To say that there was 2 options, it could have been on a carbon 1 or a carbon 2. You want to say it's on the carbon 2 here. So we have to put 2 in between the anol part to say which carbon it's on. All right, this one, again, how many are in it? Prop is the longest chain, so prop. And then determine the functional group. I see a double bond, so that's going to be ene, alkene. So we're going to add ene to the ending here. And this one, if we look at how to number this, so this could be carbon number 1 or 2. And we're going to say this bond is on the 1 because it's between the 1 and the 2. Or it could be 1, 2, 3. But this is a 1 and 2. So if we move the bond to here, it would also be on a 1. So no matter where you put it, here or here, it would be a number 1 carbon. So we do not need a 1 in the number. This remains propene. All right, so you would want to, at this point, practice naming these. That is the homework. Now, the last step is in order to draw these. So use the prefix to determine how many carbons. So F is 2. So 1, 2. Then use the name to add a functional group. So enoic acid, we would find that in here and see that it's a carboxyl. It's always on the first carbon. Well, this could be 1, 2 or 1, 2, so they're both first carbons. So I'm going to choose to put it there. And then the last part is fill in the remaining carbons with hydrogen. Every single one should have 4. So this carbon has 1, 2, 3, 4 things on it. Now this carbon has 1, 2, 3, 4. All right, next drawing. That one's done. How many carbons? Bute is 4, so draw in 4. Then use the name ending to determine the functional group. So ene tells us that we've got a double bond here, ene. And where to put it, because it says 2. So the lower number here is 1. So this is a 1 carbon. The lower number here is a 2. The lower number here is a 2. And the lower number here is a 1. So this says it goes on a 2 carbon. So it's here. Or if you were looking at that one, it's there. No matter which way you do it, the 2 is in the middle. So this goes in the middle. And then the last step, fill in the remaining with 4 carbons. And then we are done. And you can practice these drawings. So those 6 naming and 4 drawings are what you should finish.